All right, so we're going to start Unit 6, and since I haven't given you the note guide yet, I'm going to ask you to just take your notes on a separate sheet of paper. And since you're taking your notes on a separate sheet of paper, a blank paper, I'm going to actually do the same thing. So for the notes for this section, I'm going to write a big arrow, and I'm going to write it on a blank sheet of paper just like you. So this section, Unit 6, we're going to learn about circles. 6.1, circles. All right, so the first thing is a circle is not a polygon. Why is a circle not a polygon? A circle is not a polygon because a polygon was defined as a two-dimensional closed plane figure with segments as sides. Okay, a circle is two-dimensional and closed in a plane figure, but it does not have segments as sides. Remember, segments have to be straight lines, and a circle does not have straight lines. It has one continuous curve. So in our circle, go ahead and look at one. Here's my center of my circle. So this is called a circle. The circle is just the line on the outer edge. This is called the center, that point. Okay, the location of my circle is always determined by the location of the center. And you've probably heard of a radius before. A radius is a segment that connects the center of the circle to a point on the outer edge, and it could be any point on your outer edge. A circle is actually defined as a set of all points equidistant from a center. So because of that, no matter where I draw my radius, it will always be the same length. So I can draw a radius anywhere I want to on a circle. Okay, if you didn't know, the plural form of the word radius is plural of radius is radii. So weird. R-A-D-I-I. That's that. So if we were looking at more than one radius, we are actually looking at radii. So again, all radii in a circle will have the same length because that's actually the definition of a circle. A circle has an infinite number of radii, and the radius defines the size of a circle. So let's go ahead and write those down. These are some properties. So properties of the radius. Properties of radii. So all radii in a circle are the same length. Okay, I can draw an infinite number of different radii in any given circle. There are infinite different radii in a circle. And the radius is what determines the size of the circle. So I can go ahead here down below and I can draw two different sized segments. As you can see, the segment on the right is longer than the segment on the left. Now, what if these two segments were both radii? Which circle would be bigger? Well, the circle with the bigger radius should be bigger, correct? Let's go ahead and draw it and find out. If you have a compass, use a compass. So I'm going to try to draw this nicely. And same thing here. Ooh, I think I'm doing all right. So the circle on the right was much bigger, Because the radius was bigger. So again, the length of the radius determines the size of the circle. The longer your radius is, the bigger your circle will be. All right, and last thing here is circumference. We're not actually going to be calculating circumference in this section. We'll get to that in 6.7, but let's just for now define the word. What is the circumference? Most people would say it's the perimeter of a circle. So it's the perimeter of a circle. Perimeter, though, is a term that we generally hold for just polygons. So for perimeter of a polygon, we add up all of the side lengths. And this doesn't really have side lengths. So a better definition would be to say it's the distance around a circle, which is still, again, very, very similar to perimeter. They are basically the same thing. If I wanted to put a fence around this shape, I'd be looking at the perimeter or the circumference. So again, we'll remind you of what that formula is in 6.7. So for now, you just need to understand what circumference is. Oh, and one more thing I almost left out is how do we name a circle? We have 2 circles here and they have no name. So the name of a circle is always dependent on the center. So the center, let's call this center point A, and let's call this center point B. With those centers now labeled, I can name these circles. The name of this circle would be circle A. So just like with triangles and with parallelograms, we have a symbol in front of our name to indicate that this thing we're looking at is a circle. So the symbol for circle always looks like this. Looks like a little like donut or a wheel or something. Okay? The same thing here for this circle. The name of this circle is circle P. Pretty simple.